that I got you in here. It's nice and early for you, yeah? In the
Excuse
morning,
me. It's 6 a.m. in the morning.
6 a.m. That's right.
Yeah.
Other side of the world, we're 8 p.m. here in
Okay.
Australia.
Uh-huh.
Um,
Now
so
you are recording both audio and video, right?
yes, yep.
Okay.
Um, the video that I probably won't post the full video. It'll just be clips and that sort of thing.
Okay. That sounds
Um,
good.
yeah. Um, but the audio will just be on my normal podcast channel.
Okay. And you
Just with
said
me.
35 minutes or so?
Yeah, around 35 minutes. Is that all right?
Yeah, that's perfect.
All right, perfect, mate. I mean, I want to welcome you to the show, first of all. Um,
Okay.
I'm
Please go
so,
ahead.
yeah, no. Welcome, Mr. Avi Loeb, to the show. How are you?
I'm doing great. Thanks for having me.
Now, I can imagine you're so busy at the moment, flat out.
Well, we just a few days ago we had a conference celebrating 20 years for the Institute for Theory and Computation that I'm the director of, and it was a wonderful experience to see all the young scientists who came from our institute that are now leaders in their discipline internationally. They are in major universities throughout the world, and it's just like the feeling of spring that is coming now to the Boston area, where you can see a lot of flowers blooming. And I enjoy looking at that when I jog every morning at sunrise.
Oh, perfect. You
Mm.
do enjoy jogging in the morning, don't you, to start the day?
Yeah, because I enjoy being embedded in nature
Mm, mm.
much more so than talking with people, because nature is always reciprocating, and
Yep,
whatever it brings to my doorstep, I welcome.
yep.
So very often, for example, yesterday I saw wild turkeys while I
Oh,
was
wow.
jogging. There are ducks, there are birds. It's really beautiful, and all the flowers are blossoming, um, and the physical activity obviously is very good for my health. This is the way I keep myself young, and I actually did that also on the ship when I went there about a year ago to the
Hmm.
Pacific Ocean, not far from Australia.
Yep.
And I used to jog every morning on the deck of the ship. And there was a filming crew from Netflix that
Hmm.
making a documentary about my research, and the director asked, Avi, it looks like you're running. Are you running away from something or towards something? And I said both. I'm running away from some of my colleagues who have strong opinions without seeking evidence,
Yep.
and I'm running towards a higher intelligence in interstellar space.
Yep. Yep. I mean, that's perfect because the first thing I want to touch on, I mean, your book Interstellar, it is so popular. It is done exceptionally well. I'm shocked they haven't made a movie yet. I'm sure something's going to come out about it. Um,
Yeah.
have
In
you
fact,
enjoyed?
I was just contacted a few days ago about someone who might want to make a feature film out of it. Yeah.
Wow, who's going to play you? Which actor?
I'm not sure.
Have you enjoyed the media attention from it?
I think it's a way of communicating the excitement of science, because the
Yeah.
way I think of science is maintaining your childhood curiosity.
Hmm.
You know, um, the problem is that kids become adults, and they hide their curiosity, and they become obsessed with other goals that, such as impressing other people, and making money, and all kinds of political ambitions. And that's really unfortunate, because fundamentally, if we stayed like kids, we were just curious and humble and willing to make mistakes, we would discover that the world is much, much better,
Yeah,
that
yeah,
it's more exciting. And that's the way I think of science, that it's an opportunity. I mean, it's really remarkable that I'm getting paid to stay curious, and
yeah,
that's what I'm doing.
yeah. That's right. Um, and I want to discuss, your research into, I guess space trash. and the potential of extraterrestrial origins or links it may have. Because I know recently I've read some articles about things that have been found. And I won't give it away because you can explain it a lot better than me. But how is the research going into that?
Right. So I'm on the one hand, I'm leading the Galileo project
Mm-hmm.
at Harvard University. We built an observatory that looks at the entire sky all the time. And there wasn't an observatory like that before. Astronomers look at small regions of the sky very far away. And the reason we built this observatory is because the Director of National Intelligence in the United States issued 3 reports to the US Congress talking about objects they cannot identify. There are 2 possibilities. Either they are admitting that they're not competent because adversarial countries are sending all kinds of gadgets for espionage, and they cannot figure out what these things are. And that would by itself be a great reason for concern, because it's a matter of national security, and
Mm-hmm.
they're not doing their job. The second possibility is that these objects are not from this Earth. And so that's what we are trying to figure out. I mean, the government's day job is national security. My day job is what lies outside the solar system.
Mm-hmm.
So we built one observatory. We are now collecting data. There were already 500,000 objects that we looked at in the sky, and we're analyzing it with machine learning software that tells us whether there are birds, planes, drones, balloons, satellites. And at the moment, we haven't seen anything unusual as of yet. We are also building another copy of the observatory and putting it in Colorado, and a third one that we put in Pennsylvania. We just got a grant from the Mellon Foundation to do that.
Mm-hmm.
So that's one branch of the Galileo project, looking at the sky and seeing if there's anything unusual. And the second has to do with objects that collide with Earth. These are called meteors. There was one that was discovered about a decade ago by the US government satellites that saw the explosion, the fireball from this object when it exploded over the Pacific Ocean, about 90 kilometers from Papua New Guinea. And we decided to go there. I led an expedition in June 2023. And we basically scooped the ocean floor for any magnetic particles, tiny particles the size of a grain of sand. We found 850, out of which 10%, about 80, appear to be unusual. They were made of materials, a chemical composition that was never found for materials that came from the solar system, like on Earth, Mars, the
Wow.
moon, or asteroids. So we think this object came from outside the solar system. And of course, the reason for doing that is because the US government satellites detected the speed of the object, and it was higher than needed to escape from the solar system. So it cannot be bound by the sun's gravity. And finding those materials allowed us to completely independently find additional evidence that this object was from outside the solar system. And so we hope to to study more materials from interstellar objects, perhaps even get bigger pieces, so that we can tell whether it was a rock that came from another star, or maybe even a technological gadget. And so that is what I'm looking into.
Yeah, I mean that's so exciting. It's really exciting stuff. Um, I mean, I'm sure you get asked this a lot, but I mean, how likely do you think it is that we have had, some advanced technology on this earth before? Is it something that you think has been here before already?
Well, that's an excellent question. We don't know. I mean, the human species, just came to Earth a few million years ago, and that's one part in 10,000 of the age of Earth. And so clearly there could have been a lot of things before us, and we tend to think that they were less intelligent, but it's not necessarily the case. And about 232 million years ago, there was a big global warming event that came after um, an explosion of species that came to Earth. It's called the Cambrian explosion, and it was terminated by global warming similar to the one we are producing with our technologies now. And it's possible that that was triggered by another civilization that predated us, because that corresponds to a small fraction of the age of the universe, just 5%, the latest 5%. The other thing to keep in mind is around the same time that Australia was connected to Africa, which was connected to Europe and the Americas. They were all part of a supercontinent. And just think about it, that 200 million years ago, we were all connected, just similar to the words of John Lennon in his song Imagine. Imagine the world being one. And the dinosaurs back then had a world that was just one, a supercontinent. We could have driven a car from Australia to Africa to Europe if we were to live just 5% back in Earth's history. Things, there are lots of things that we are just not aware of that may have existed back then. And of course, there is the possibility that we were visited from another star, because most of the other stars are billions of years older than the sun. They were formed before the sun. The sun is a late bloomer. It only formed in the last 1/3 of the age of the history of the universe. And so civilizations like ours could have easily developed. There are hundreds of billions of stars in the Milky Way galaxy alone. And, if they develop the technologies to travel, even with our own spacecraft, you could traverse the Milky Way galaxy from one side to the other in less than 1 billion years. So they could have arrived here, and we don't know when and if, but they could have even planted the intelligent life. We could have had an interstellar gardener that created life on Earth and that seeded life on Earth. And we just don't know that. One thing we know is the Earth, for example, didn't have oxygen to start with. And then for some reason, 2 billion years ago, cyanobacteria started blooming here. And it wasn't clear what triggered that. And it could have been an interstellar gardener, or even a rock that came from another star that, brought the life as we know it to Earth, that made an atmosphere that is rich in oxygen. And that wasn't the case to start with. All the life forms that existed before that happened, they were based on life without oxygen, and they were completely destroyed by the oxygen that started filling up the atmosphere. So there is a lot that we don't know, and we should be open-minded and just explore the possibilities.
And regarding our solar system, is it likely that there's some sort of life in our solar system? Because I know there's a lot of work going to, I think, one of Saturn's moons as well.
Yeah, so there is a moon of Saturn, and that's the only other body in the solar system that has liquids on its surface, in addition to Earth. Earth has liquid water on its surface, and this moon, which is called Titan, has liquid methane and ethane. It has actually a temperature that is, it's only 90 degrees above absolute zero. So it's, less than, if water existed, and it does exist under the surface, it's frozen on the outer layer, and then underneath there might be some liquid. But on the surface, there is liquid methane and ethane, and there are lakes and oceans and rivers and everything. So if I had my wish, I would go there and fish in the ocean. And of course, if you find a fish in an ocean of methane,
Yep.
you don't want to eat it because it will be quite bad for your health.
Yeah, yeah.
So I will not eat those fish, but if we do find life there, then it's life as we do not know it. Because the chemistry of life as we know it is based on liquid water. And that would be fantastic to find. And actually, NASA just announced, approved a mission last month that will go to Titan. It's called Dragonfly, and it will
Yep.
go to various locations and look for any traces or signatures of life. And, that would be very exciting because I realized that if life exists on Titan, which is basically so cold, relative to Earth, and it's minus 180 Celsius or so, then it's also possible that life existed in the early universe everywhere, because if you had rocks like Titan around, actually the average temperature of the universe was 90 degrees above absolute zero when, and that was after the first stars formed.
Yep.
So everywhere in the universe, you had the same temperature as the surface temperature of Titan, and you didn't need to have a rock close to a star like the sun in order to maintain that temperature. So it opens up the possibility that life existed very early in the universe, maybe, about 100 million years after the Big Bang, very early on. So I'm very excited about the prospects of searching for life on Titan.
Mm, mm. I mean that's really exciting. I did read that you were doing some work with Dragonfly and NASA. I mean, I hope, fingers crossed, that
Yeah, it's
something
2020.
happens.
It's 2028, and it's
Yep.
only, it's only 4 years away, and so hopefully we'll get some good news from this mission.
Yeah. Is it? Do you think it's crazy to think that when you look at, say, ancient civilizations on Earth, how they had uh, many gods and that sort of thing, that there could have been some sort of extraterrestrial life that was there, or is the whole idea of God something more, than just a spiritual thing? Is there potentially something more advanced that we had on Earth at one point?
Yeah, well, think about Moses. There is this story in the Old Testament that Moses witnessed a burning bush that
Mm-hmm.
was never consumed, and just watching it convinced Moses that God exists, which is a superhuman entity. Obviously, today you could buy online a bush that will never be consumed that would impress Moses. And it's just modern technology to
Yeah.
do that. And so what that means, this example, is that if we were to witness technologies that represent our future, that are already in possession of other civilizations near other stars, then we could be as impressed as Moses was, that there is some superhuman intelligence that can make things that we feel religious awe when we look at. And so my point is that a very advanced technological or scientific civilization is a good approximation to God.
Yep.
And it could potentially create life in its laboratory. It could create even a baby universe in its laboratory, because once you understand how to unify quantum mechanics and gravity, you might be able to create a baby universe. And so these are attributes that we related to God, and might be in the real universe related to advanced scientists or other civilizations. And so what that means is, well, first of all, it may mean that the Big Bang was not anything but a laboratory experiment, that
Yeah.
maybe we exist as a result of another civilization that created the Big Bang. And then if we are able to advance to the level where we create universes, then it's just like babies become adults and make babies and so forth. And that may explain why there was a Big Bang. But beyond that, I think that the traditional religions brought a sense of modesty, because people said, oh, there is a superhuman entity. We should, we should realize that we are not at the top of the food chain.
Yeah.
And then came Friedrich Nietzsche, the philosopher, in
Mm-hmm.
1882, and he said that God is dead. Okay, and then after that there was the hubris of science and technology, and a lot of people, secular, most people are secular, and they believe that there is nothing more intelligent than we are. So this sense of arrogance will be removed if we meet at some neighbor that is far more advanced than we are.
Yeah.
And so there is I think it will bring back this sense of modesty that used to be part of traditional religions, and it's actually good for people to realize that there are things more intelligent than we are. And actually the first sign of that will come with artificial intelligence, because AI systems are getting to the point where they will be smarter than humans. And it's just like the feeling I get when I speak with my daughters. Even though I gave birth to them, they could be smarter than I am. And
Yeah.
the same would be true with AI. And that would give us a sense of, there will be sort of the first aliens that we ourselves created that
Yeah, that's
are
right.
better than us.
Yeah, yeah. And something else I wanted to touch on, which I know you've spoken about it a bit. Where do we stand as a civilization regarding a cosmic exodus? Do you believe it will happen? And when? How long away are we from potentially doing that?
Yeah, so indeed, there is this biblical story of Exodus, that a nation broke the chains of slavery and left Egypt. That was the Israelites, and they became free, and they went to the promised land. And you could think of a metaphor that this story is basically just a metaphor to humanity leaving Earth and going to interstellar space, and as a result of realizing that there is a promised land out there, and that there is much more real estate in space than we find here on
Yeah.
Earth. And unfortunately, we are obsessed with zero-sum games on Earth and territorial disputes, and there are two wars right now on that. And there is, if we were to just look up and realize how much more there is to the universe,
Yeah.
we would be freed from these obsessions. And to me, that the story of Exodus is a metaphor, and I hope that in the future we'll explore space. And if I was given a one-way ticket to go to space, I would definitely take it, because I'm so frustrated with the fact that a lot of people are not behaving
Yeah.
intelligently. What do I mean by that? I mean, we live for a short period of time, just less than 100 years for most of us.
Hmm.
And nevertheless, we shorten it even more by engaging in conflicts. And that's not an intelligent thing to
Yeah.
do.
Yeah.
It makes no sense. And so I do hope that we would change our priorities by realizing what is out there and go to space. And humanity at some point will not just be limited to a single planet.
Mm. Do you think Mars is a real possibility, or is it just
Um,
Elon is just, good for business?
well, definitely not the surface of Mars, the way Elon Musk is talking about,
Yeah.
because if you are exposed to cosmic rays, to energetic particles for more than a few years, your brain will be damaged beyond repair. And at the moment, there is no good solution to that. And so one possibility is to go to Mars and live in caves, just like humanity, humans started in prehistoric caves, and we might end up in caves if we go to Mars,
Yeah.
because the caves protect the human body from all those energetic particles on the surface. Also, the surface temperature of Mars in the equator changes by hundreds of degrees between day and night. And it's just impossible to live there. So it makes the only place that makes sense is underground, where the temperature variations are lower and the environment is protected. And actually, the first thing I would do is actually check if there is any life or any signs of life that existed before in those caves. That was never done by NASA. But it's a huge undertaking to, go into the caves and then start preparing them for human life down there with all the resources, all the nutrients, everything we need. And so it will not happen anytime soon. I don't think so. Maybe we'll start with the moon and build some infrastructure there to demonstrate that we can do it, a human habitat there, and then move to Mars. But it will take probably centuries before we do that. And for now, we need to. I mean, I think it's not clear that we want to send humans to space. It's possible that we can send AI astronauts. These are intelligent, autonomous probes that will be sent out and do whatever we want to achieve accomplish in space. And when you look at the dandelion flower, it doesn't send copies of itself. What it sends are seeds that carry the information, the DNA, and these seeds replicate the dandelion flower in other locations. And so we can do the same, send the information in the form of AI systems that we could reproduce whatever we want using the raw materials elsewhere.
Yeah. And I recently read something you put out a couple of weeks ago on the theory of negative mass. And how time travel comes into play there. Can you just explain that for people who probably never heard of it?
Yeah, so that's something that is not appreciated even by some scientists, physicists, because I got emails of people who didn't really fully understand it. So there was an idea that was proposed back in 1957 by a physicist named Herman Bondi, a British physicist. He said, according to Einstein's theory of gravity, general relativity, you could in principle have negative masses. What that means is a positive mass that we are all familiar with generates gravity that is attractive. So objects are attracted to each other. But if you imagine switching the sign, just like with electric charges, you can have positive and negative charges. So if you had a negative mass, it will repel objects away from it. And the only issue is that if you had that, you can put a negative mass next to a positive mass. So the negative mass will push away the positive mass. The positive mass will attract the negative mass. So they would move together and accelerate indefinitely up to the speed of light. Which is a strange propulsion method, because you don't use any fuel, and yet this pair of objects, negative and positive masses, will just accelerate indefinitely. Now, the problem is, and a lot of people said, oh yeah, that's great to have a negative mass, maybe it's a propulsion method. And what I pointed out is that if you imagine a negative mass and you just send a photon, a particle of light next to it, what happens near a positive mass is that the photon gets delayed, the light gets delayed as it moves near a positive mass. This is a result that was derived by a physicist named Erwin Shapiro. It's called the Shapiro delay. He's actually a colleague of mine at Harvard. And the Shapiro delay is well known. It was measured in the solar system, measured in gravitational lensing, and many other places. And if you replace the positive mass with a negative mass, instead of getting a Shapiro delay, you get a Shapiro advance, where the light that passes near this object, negative mass, is actually advanced in time. So instead of being delayed, it's actually going faster than light. And that means that I can build a time machine, Whenever you can travel faster than light, you can build a time machine. And so that means that in principle, if we had a negative mass, you can go back in time and kill your grandparent.
Yep.
And that makes little sense, and it violates causality. So you could use that if you believe in causality and that you cannot visit your past, and basically, logically speaking, it makes no sense that you can kill your grandparents.
Yep.
So in that sense, if you believe in causality, then you have to reject the idea of negative masses. And that's what I pointed out. And you would think, oh, well, that's hypothetical. But no, but actually, the universe is expanding at an accelerated rate. We know that. And it's the effect of repulsive gravity from the vacuum. It's called the cosmological constant. And for the same reason, you cannot take part of that dark energy that makes the cosmological constant or gives the accelerated expansion of the universe. You can't carve out, engineer that dark energy and try to make a negative mass out of it. And so that's something important to keep in mind. If you believe in causality, there cannot be negative masses.
Yeah. Is it hard dealing with the mainstream science media? Do you find that they?
Yeah, I mean, it's really, a lot of the media is looking for clickbaits, and that includes even the best newspapers. I can give you an example. When we went to the expedition to the Pacific Ocean, we were guided by the location of the fireball based on data from the U.S. Government, from the satellites of the Department of Defense. And we also checked, there was a seismometer in Papua New Guinea, and we checked that it indeed, it had some signal around the time of the explosion that was consistent. And then some scientists, some scientists are jealous of the media attention that I'm getting. And so they really wanted to, basically ridicule or push back on it. And so they looked at the data from that seismometer and said, oh, actually, this could have been a truck. And they went to the wrong place. And so then the New York Times came out with a title saying the meteor was actually a truck. And I wrote to the editor and said, look, this is ridiculous. We were relying on the U.S. government satellites that saw the explosion. The light from the fireball has nothing to do with this seismometer. How can you claim that the meteor was a truck? Which is a ridiculous statement. And they didn't remove the story from the online posting that it had. The science reporter who wrote it clearly didn't even check what what was the background information around the expedition. He just wanted to ridicule it. And if the New York Times does it for science, then think about how distorted is the news about politics. Because in the case of science, there are at least some underlying facts, and like the U.S. government detected it with satellites. You have to discuss that. You cannot ignore those facts and talk about a truck. It's ridiculous. But obviously, you can say that if you want to get clickbaits, and if you want to make some fake news articles where you make fun of something. And unfortunately now, I've seen it in many other contexts, and you can't believe what you read. And obviously some of the stories are obviously factual and correct, but there are many that are not. And this trend will get even stronger with AI that can easily write stories. I'm really worried about that.
It's incredibly frustrating. And I can imagine how frustrating it is for you. I can't believe how much of the media and a lot of mainstream science push back against extraterrestrial and advanced technology. It's so many of them.
It's really unfortunate because the public cares a lot about it. The public is fascinated, and then you see people pushing back as if they are saying, we don't want to hear about it. We sort of have an opinion on it. But that's not the way science is done. You have to collect evidence.
You're right. The public wants to learn about it. They want to see more about it. They want to, understand what's happening. And I feel like it's easy for them to to shut it down. You know, they say, "Where is the evidence?" That's what they say. Where is the
Well,
evidence for aliens?
but you see, the problem is that if you're not seeking evidence,
Mm.
you will never find it. So, when Elon Musk says, I haven't seen any evidence with all my communication satellites. Well, the satellites are not equipped with cameras that will
Yeah, yeah,
give
yeah.
you information on unidentified objects. They don't, they cannot really do the job. And we know that you have to invest $10 billion in a particle collider like the Large Hadron Collider in order to find the Higgs boson. You have to invest $10 billion in the Webb telescope in order to find the first galaxies. You can't imagine knowledge falling into your lap. Suppose Elon Musk was looking around with his satellites and saying, I don't see any evidence for the Higgs boson, therefore the Higgs boson does not exist. Of course you
Yep.
don't see any evidence because you need to build a special purpose type of instrumentation for that. And that's what science is all about. It's all about hard work of collecting evidence and learning something new.
Yep.
So having an opinion is very easy. Saying what we think about aliens or extraterrestrials is very easy. Doing science fiction is really easy. The point is to do the real science, not the fiction part. It takes a lot of work and effort. And if you say it's extraordinary to claim that we are not alone, you are not seeking the evidence for against that. And so the point is that extraordinary evidence requires extraordinary funding
Yep.
and effort, and without putting that effort, to do the expedition took us a year of planning, $1.5 million, several weeks in the ocean, and then 9 months of very detailed laboratory work to analyze the materials. And all of that is a lot of work. But then people were looking at it and said, oh, yeah, you just went to the wrong place because there was a signal in a seismometer that could have been just a track. That's easy to do. That's easy. And it will get publicity, but it's not the way science is done.
Yep.
And when I went to the Pacific Ocean and wrote a diary reports about the hard work that we did, there were millions of people around the world that read them in real time, and these reports were translated to Spanish. And the general public gets the point that it's exciting to do science. It doesn't need to be boring. However, a lot of scientists want to keep it boring. They don't want the public engagement on things that might be exciting because they are jealous of the attention that some subjects get. And moreover, anything new is being pushed back against. I mean, you can see what happened, for example, to Wegener, Alfred Wegener, who proposed this idea of continental drift that made all the continents drift apart. And that's the thing we talked about at the beginning. And,
yep.
He was ridiculed. And then he died, and 20 years later, it was realized that there is evidence the rocks in different continents match, and vegetation matches. And of course, now he's celebrated as the founding father of plate tectonics. And the point is that it takes a long time for people to accept ideas that deviate from traditional thinking. But we should learn from history and realize that, we should allow people to come up with original ideas, and they might look crazy at first, but eventually they might represent reality. If they're crazy enough, they might represent reality. And actually thinking that we are not alone is not crazy. I mean, we sent equipment to space, in the last 50 years, 5 probes to interstellar space. So why should we assume that nobody else did that in the Milky Way galaxy? Why shouldn't we check for that? So to me, it sounds like common sense, but common sense is not common in academia.
Yeah. Is it? Do you think there's a level of acceptance in perhaps the government with this thing, but they don't want to alarm the public? They don't want them to get too crazy about the subject of alien, or do you think they're just ignoring it?
Well, it's possible. I think the government plays a different game. The government has technologies, new technologies that they are developing for military purposes and national security purposes. So they want to create some buzz, about things that may have come from other places, other stars, just to keep the noise level high enough. So if people see something in the sky, they might say, oh, well, maybe it's an unidentified object that came from another star. whereas in reality, it's some advanced technology that the US government developed. I mean, that's a game that
Yeah.
I'm sure they would like to play. But in addition, they might also have some real things that they noticed over the years, and they want to keep it quiet so that the public doesn't get, so that it doesn't create some instability.
Yeah. Yeah.
I haven't seen that kind of data. It may
Hmm.
well exist. Other people talk about it.
Yeah. Yeah. Oh, there's just so much to know. There's so much we don't know, which makes it
Right.
all so much more exciting.
Yeah.
Really, and that's why.
Yeah, life should be exciting. I don't see, I mean, as kids, if you remember your childhood, it was
Yeah.
probably very exciting. I mean, to find new things, to, take risks. And, going against the wind is actually a lot of fun. That's what I'm doing now with this research. Um, just I had an exchange just a few days ago with Neil deGrasse Tyson
Mm.
because he was commenting on a paper where I explained some new results, new experimental data that suggested that we detected gravitational waves from the universe. I suggested that it's actually the jitter of the solar system as a result of asteroids moving around. And I wrote a scientific paper about it. So he wrote to me and said, it's great to see you suggesting something mundane, something simple to explain something more exotic.
Mm.
Because previously, when you talked about interstellar objects, he said you did the other thing. You tried to explain something simple with a more exotic possibility. And I told him that I enjoy going against the wind and that he should try it sometimes,
Yeah.
because what he does as a science popularizer is just go with the wind. He always agrees with whatever the scientists are saying. He doesn't practice science right now. He's
Yep.
just going with whatever. And the point is that science is work in progress. And quite often scientists are wrong because we don't have the full data. And it takes a lot of courage to actually collect new evidence for things that go against the wind. And that's what I'm doing. I suggested to him to try it as well.
Mm-hmm. That's what I love. I mean, you've got no social media, you've got nothing. You've got nothing to prove other than the real science that you're trying to discover, which is why we're so
Exactly.
lucky that we have someone like you to be able to do it and try and find this information for us. So, I mean, I want to thank you. I know it's so early over there. It's 6 a.m. for
Oh, it's
you.
not so early because I usually jog at this time.
Oh no, I've
Um,
ruined your jogging now.
yeah. So the only thing that happened this morning is that I delayed my jog. It will not be sunrise anymore, but it will still be beautiful.
No, that's right. As long as you go and you can clear the mind on a jog, that's all that matters. I want to thank you
Exactly.
so much, Avi. I really appreciate you coming on. And where can people find more information? Where can they find it?
So every day or two, I post an essay on medium.com. So you
Mm-hmm.
can subscribe for free. You just need to Google Avi Loeb, Loeb, AVI, at medium.com, and you will find it. You can subscribe to it. There are also books that I wrote recently.
Yep.
One is extraterrestrial, the other one is interstellar. And I'm starting to work on the next book. There will be a Netflix documentary coming out in
Yep.
2025. And also I appeared in the annual TED conference a few weeks ago.
Mm-hmm.
That video should come out hopefully in the coming months.
Perfect. And you've been on a lot of podcasts as well. I know I
Right.
listened to you on I think Modern Wisdom recently. That might have been a couple of years ago, that one. But you've been on so much as well. So people can find it. I'll drop some links as well in the information below once I post so people can get easy access to it. So again, I want to thank you so much. I hope you enjoy your run, enjoy your day, and you discover what you need to discover for us, for the people watching.
Thank you so much, Daniel. And I don't see myself any different than any other person.
Yeah.
I'm just privileged to be able to pursue my curiosity and not pretend that I know more than we actually know.
Perfect. And that's how it should be as well.
Thank you.
Thank you. Thank you.